In the 1850s, Robert Bunsen and his research collaborator Gustav Kirchhoff conducted a series of experiments to determine why substances emitted specific colors when placed in a flame. The color they determined indicates what elements are present in the substance. For example, if sodium is placed in a flame, they observe shades of yellow. Copper, shades of green. Strontium, shades of red. That was a good one. While watching the experiments, Kirchhoff was reminded of how a prism spreads light into a rainbow of colors. So, using a prism and the pieces of a small telescope, Bunsen and Kirchhoff built the first spectroscope, an analytical device they hoped would help them see the spectra coming from heated substances. And it worked. As an element was put into the flame of a Bunsen burner, the light from the heated substance passed through the prism of the spectroscope, where it then spread into a ribbon-like spectrum of colors, riddled with dark lines. The combinations of bright colors and dark lines were like barcodes indicating what atoms were present. When burned, each element produced a completely unique spectrum. Using their spectroscope, Bunsen and Kirchhoff were able to discover two new elements, cesium and rubidium. One day, Bunsen and Kirchhoff decided to test their invention with sunlight. It produced a spectrum that featured two lines that were identical to those in the spectrum produced by sodium. Bunsen and Kirchhoff had discovered the presence of sodium in the sun, 93 million miles away. Suddenly, scientists had a tool to help them study the chemistry of the heavens.
Liftoff. We have liftoff.
Today, the legacy of this great discovery lives on in the exploration of space. A form of spectroscopy is being used to study the atmospheres of planets, to search for signs of water, signs of life.